Okay, this is video 1 from Unit 6, Lesson 1. We're going to apply the rules of integer exponents to simplify expressions. So what we're going to do is we're going to look at each of the rules individually and then do some examples. So our first rule is a multiplication rule. We multiply a common base. So our common base is A. What you do is you add the exponents. So I would add n plus m. For example, my common base is x. I would add 2 plus 3. So I keep the base the same, and I add the exponents. Likewise, if you're dividing a common base, you would subtract the exponents. So keep the base the same, and then n minus m. Okay, for example, so my common base is b, and I'm dividing, so I subtract the exponents. 5 minus 3 is 2. If you have an exponent outside of the parentheses, so this is a power to a power, then you use something like the distributive property, and you're going to distribute that exponent to each of the bases inside. So I have two different bases. A and B are not the same. And so I'm going to distribute the m to each one. And I multiply. So I'm going to do A, and then it'll be n times m. And then B, B's exponent is 1 if there's not 1 there. So 1 times m, which is just m. So if this is my example, I'm going to distribute that 3 to both the x and the y. And I multiply the exponents. One times 3 is 3, so x cubed. 2 times 3 is 6, so y to the 6th. Same kind of thing for this one. I'm going to distribute the n to each of the bases. So I have base A and base B. I will keep it as a fraction. So for example, if I have s over t and I want to cube that, I will get s cubed because 1 times 3 is 3 over t cubed. Okay, if you have a negative exponent means you're going to move your base. You're going to move your base. If it's in the numerator, then you're going to move it to the denominator. If it's in the denominator, you'll move it to the numerator. Okay, so this negative exponent tells me that I'm going to move this base to the denominator. I don't see a denominator there, so I just make one. once you move it, your exponent becomes positive. We can't leave an empty numerator, so I'm going to put a 1. So if I have 3 to the negative second power, I'm going to have to move that to the denominator. My exponent, the 2, becomes positive, and I put a 1 on top. Now, 3 squared, that's a small number. So if you have an exponent less than 5 with a number, go ahead and evaluate that number. So go ahead and do 3 squared, which would be 9. Okay, a couple more. All right, so first thing I have to do is I have to distribute this exponent to both numerator and denominator, both bases. Now, because they're negative, the A has to move to the bottom, the B has to move to the top. Once you move them, the exponent becomes positive, so my ends are now positive. So if I use S over T again, and then we'll do negative 3 instead of 3. Okay, so you distribute the negative 3 to each base, and then because they're negative, they have to move. Our last rule is very easy. Anything to the 0 power is just equals 1. So no matter if it's a number or a variable, you take it to the 0 power, it equals 1. So if I'm taking this whole entire thing, 500xy to the 0, that whole thing equals 1. There are our main rules. So what we're going to do now is just practice some more examples. I would write these rules down in your notes. And then as we're going through these examples, pause them, try to work them out on your own, and then you can play to check that to see if you got them right. Okay, x to the 4th times x to the 8th. So I have a common base that I'm adding, or that I'm multiplying, so I would add the exponents. So 4 plus 8 is 12. Okay, here I have an exponent outside of parentheses, so I have power to power. So I will multiply the 4 and the 6. 4 times 6 is 24. Same kind of thing here. I have 2 different bases though. I have a 3 and a y. So I have to distribute that 2 to both bases. So 3 is a number, but that's still a base. Your bases can be numbers or variables. Okay, so I have 3 to the 1st times 2, and then y to the 5th times 2. So that is 3 squared times y to the 10th. Now 3 squared, that's a small enough number for us to evaluate, so I'm going to write that as 9. So the answer would be 9y to the 10th. Okay, same thing for this one. I have two different bases, so I'm distributing that 4 to both. So 3 to the first times 4, so 3 to the 4th. X to the first times 4. X to the 4th. 3 to the 4th, I can evaluate that number as well. If you type that in your calculator, you get 81. So if you have an exponent with a numeric base, then if the exponent is less than 5 or less, go ahead and evaluate it. Okay, this next one is a little bit tricky. I have 2x to the 5th and I have 3x to the 8th. I see parentheses, and parentheses make me want to multiply. However, I don't have any exponent outside of the parentheses. So these parentheses here are just telling me that I'm multiplying. So if I rewrite it using a dot instead of the parentheses, then I think it becomes a little bit easier. Okay, so remember, common bases are what you can combine. 2 and 3 are not common bases. So I'm not adding their exponents, but they are regular numbers, so I'm going to use the regular operation. So I'm going to just do 2 times 3, because that's the operation, and I'm going to get 6. Now my x's are common bases. So when I combine those, my base stays the same, and I add the exponents. 5 plus 8 is 13. Some more examples. Okay, 26 and 19, I'm dividing this common base, so I will subtract. My base stays the same. 26 minus 19 is 7. Same kind of thing over here. Couple steps I have to do though. So first of all, 36 over 20, those are not a common base, but they're regular numbers. So I'm just going to divide, because that's the operation that's there. And I get a decimal, so I need to leave these as reduced fractions. So I'm going to reduce that fraction, 36 over 20. Okay, so if I do that, I get 9 over 5. So I still have a fraction, which is why I have a bar there. Okay, my y's are a common base, so I subtract exponents. 2 minus 9 is negative 7. So after you subtract, put it in the numerator. Then, if you see that it's negative, like we do here, we have to move it to the denominator. Once you move it, the exponent becomes positive, so you get a positive 7 with the y. Okay, same thing here. I have regular numbers out front, so I'm going to divide 75 over 50, but I need to keep it as a reduced fraction. So I'm reducing 75 over 50. That reduces to 3 over 2. And then I have a common base here, so I subtract exponents. If you don't see an exponent, remember there's a 1 there. 8 minus 1 is 7. Put it in the numerator. If it's negative, you need to move it, but if it's not, then it stays where it is. 7 is positive, so we stay. Okay, a few more. All right, 3m squared t to the negative 2. So I don't have any common bases, but I have a negative exponent. You can't leave negative exponents in your answer. So I need to move this to the denominator. Remember, if there's not a denominator there, you make one. Once you move it, the exponent is positive. Everything else stays put. So that means on top, I still have 3m squared. Okay, I need to move my -3. And then I can't leave a 0 exponent either. Remember, everything to the 0 power is 1. So first of all, I have to move my n cubed to the bottom. And then w to the 0, that's just 1. So on top, all I'm left with is 1. Okay, the next one that I'm looking at, I have this n to the -1 over w squared. So I can't leave a negative exponent. N and w are not like bases, so I'm not subtracting exponents. I just need to move this to the bottom. Okay? So that becomes n to the first. Technically, you don't need the 1 there. N and n to the first are the same thing, but I'll keep it there. It's fine if you do. The w squared is not negative. So that stays right where it is. It does not move. Okay, I don't have anything left for my numerator, so I have to put a 1 there. We can't leave an empty numerator. All right, and then this final one, w and n are not like bases, so I'm not subtracting, but I can't leave a 0 exponent. W is 0, I need just 1. So nothing wrong with the end of the fourth. It's going to just stay exactly as it is. Okay, so these just take time, they take practice. This video is a little bit longer than most of the videos are not quite this long. But we really just needed to get into the examples. All right, so now you're ready to do Unit 6, Assignment 1.